Hello everyone, welcome to Traveling Around the World with Mathematics. Because of the COVID-19, in this year we are unwilling to travel abroad. But in here, I'm going to share some math concepts and stories from different countries. So please hold on your ticket over there, and we're going to visit our first country. Okay, so the first country we're going to visit Egypt. And in this country, we're going to show you the numeral system. So when it comes to numeral system, you may come up with Arabic numeral, just like the number in this clock, right? We are very familiar with. But we know that the Arabic numeral system is invented by people. So before people invite this system, what can we use anything to represent the number, the concept of number? In Egypt, they use the object in their daily life. So you can notice that they use a stick to show number 1, a hammer show number 10, and a rope's lotus plant, finger, frog, and god. They use this symbol and this object to show the numbers. So for this number is mean 1 million, and they use the god to represent 1 million. So we can know that 1 million at that time is a very big number because they use the god to show this. We know the God is powerful, right? So 1 million is a great number at that time. After we introduce this kind of symbol, we can use those symbols to show every number. For example, we want to show the number 1342. We know this number is 1000 plus 300 plus 40 plus 2. So we know that for 1000, we can use a lotus plant to show it, right? So 1000 is 1 times 1000, so it's a lotus plant. And for 300, it's 3 times 100, so we can use 3 ropes to show 300. And 40, 4 times 10, so we can use 4 hammers to show 40. And for 2, number 2 is 2 times 1, so we use 2 sticks to show number 2. So for the number 1342, we can use the symbol like this to show the number. So we can use the same system to show every number, every integer in our daily life. So in this part, we only introduce the positive integer. So later we're going to share the fraction. So this is part for Egyptian numeral for integers. Before we introduce fraction, there's a story of Horus. He's a god of Egypt. So after a war, Horus lost his left eye. For this story, Egypt people know that Horus lost his left eye and his eyes was separated in many small parts. And this small part will become the earliest fraction. So for each part, it means a small number, like this. Each part is mean 1 over 2. 1 over 4, 1 over 8, 1 over 16, 1 over 32, and 1 over 64. So this kind of number in Egypt is say their fraction. And in math, we will say this kind of fraction is unit fraction because the numerator was 1. And Egypt people noticed that they can use the unit fraction to express every proper fraction. So the proper fraction like this is 5 over 8. But 5 and 8 is Arabic numeral, right? But at that time, there's no concept of that. So Egypt people noticed that they can use 1 over 2 plus 1 over 8 to express 5 over 8. So at that time, Egypt people just invite the system of fraction, and they can use this system to show every kind of proper fraction. This is part of Egypt number for integers and fractions. After we introduce integer and fraction, over here, here's stone, and we send the message on this stone by the integer for Egypt number. So if you have chance, you can come to here and see the Egypt number over here, and you can discover the message we sent over here. Okay, so if we are prepared, we can go to our next country. So let's go. The next country is Mexico, and in Mexico there's an ancient culture named Maya. You may listen this culture in some movies, right? And in Maya numeral, they only use 3 items, 3 symbols to show the numbers. In Egypt, we use 7 objects, right? So we use 7 symbols to show the integers. In Maya, they only use 3 symbols. So they are a shell and a stone. A stone means a dot and a stick for number 5. So a shell means 0, a dot, a stone means number 1, and a stick means number 5. So if we want to show the number 7, we know 7 is 2 plus 5, right? So 2 is equal to 2 times 1. So we can use a 2 dot and we draw a short segment for a stick. We can use the same rule to show 12. 12 means 2 plus 10. 2 is 2 times 1 and 10 is 2 times 5. So we can use 2 dots, 2 stones and 2 short segments to show this number. So we can use the same rule to show the number from 0 to 19. But you may be confused that how about the number greater than 20? If we want to show the number greater than 20, how can we use it? We will use another system. It's known as 20 base. It's really similar to 10 base system we use in this year. Okay, so how to use the 20 base system? If you want to show the 20, they will become 2 layers. The first layer is mean how many 20. So a dot means 1. We have 1 20, and 0 is mean 0 1. So 1 times 20 plus 0 times 1 is equal to 20. Okay, so we can see another numbers like 100. So for the second layer, it mean a short segment. It mean 5, right? So 5 times 20 plus 0 times 1 is equal to 100. So for the greater number, it's the same concept for this one. The number 4 plus 15 is 19. So we have 19, 20. 19 times 20 is 380. And the shell is mean 0. 0 times 1. So 380 plus 0 is 380. So we can use the same rule to find all integers. But you will notice that if the number is greater, the layer is more. So it's a pros and cons for the Maya numeral. So it's a really cool numeral system in Mexico. After we introduce the Maya numeral system, and we know that the Egypt numeral system and the Maya's numeral system, we all use the object from our daily life to show the number. But later we're going to show you the third countries. They're not going to use the object from our daily life. They'll use another concept to show the number system. So let's go to our next country. So the third country we're going to visit Italy. In Italy there's a famous city named Rome. So we're going to introduce the Rome numeral system. So it's not same as the previous country. The previous country we use the object from our daily life to show the number, right? But in numeral system, we use a gesture from our hand to show the number. So if you ask me what's number 1, I will raise a finger to show number 1. And it looks like the capital letter I, right? So we use the I to show number 1. And I have 5 fingers, so I will get the letter V. So we use a V to show number 5. And I have 10 fingers, right? So look at my thumb. I cross my thumb so I can get the letter X. So we use the X to show number 10. So we can use our gesture to show 1, 5, and 10. How about number 2? I raise 2 fingers. 3 for 3 fingers. But there are some rules, some restrictions for Rome numeral system. The same symbol can only become 3 times. So for number 4, for ISIS, no, they can use the same symbol for 4 times. So there's second rule. The second rule is addition and subtraction. So if we want to add some number or minus some number, we will use the second rule. So we know number 4 is 5 minus 1. So if we want to minus a number, we will put the symbol on left hand side. So number 4 is IV. It means 5 minus 1. And for number 6 is 5 plus 1. So we can add the number. So we will put on the right hand side. So the 6 is equal to 5 plus 1. So its symbol will look like 5 VI. So we can use the same rule to show many integers. But we can know that the integer is infinity, right? There's so many numbers. So for the larger number, we will use a Greek letter to show them. It's not from our gesture. So L is mean 50, C for 100, D for 500, and M is for 1000. After we learn the Roman numeral system, we're going to come here and check whether we really understand it or not. Okay, so let's see this wheel. Here are 2 wheels. For the smaller one, the number on it is the Arabic numeral system's number we are very familiar with, like 2, 14, 1, 19, and so on. And for the bigger one, the number over here is the Roman numeral system's number, like this, XX. 2x is mean 20, right? X plus x is 10 plus 10, so it's 20. So we can turn this wheel to the number 20. So if we match 2 numbers, you can see the color will be the same. So you can use this way to check whether you found the number or not. So you can come here and play this wheel. So this part for these 3 countries is our first part. We're talking about numbers from different countries. Okay, so next part we're going to introduce another concept of math. So let's go. For this part, we're going to introduce geometry in math. So geometry, you will get the beautiful pattern like this. So you can notice that geometry is not only for math, but also for art. So here's a machine we can decide or we can create our own patterns, like a circle. So you stand in front of the machine and the camera will scan your clothes. And you can wave your body, right or left, change the color, and you can forward and backward. Also, you can change the color of this picture. After you see the picture with you, which one you are really like it, you can raise your hand, and it will show you. You'll come to create your own pictures. And look at the camera, it will have a photo for you. Okay. So after you finish the picture, here's a QR code. You can scan it and we will send this picture for you. Okay, so this one is for this machine. We will create a beautiful pattern for you. Okay, so now we're going to introduce this picture. Where can we see? Okay, so let's go to the country of this picture. Now we're going to introduce France. And we just get the picture from the machine, right? It's really similar to this picture. And this picture is from the famous cathedral in Paris. And this picture is from the part we call them window frame. And we're going to talk about the math concept in this window frame. So look at this. If I draw the line through the center like this, the upper side and the lower side is the same. Their shape and their size, all of them are the same. If I cut the line through the center vertically, the left hand side and the right hand side, their shape and their size is also the same. So we will call this kind of pattern line symmetry. So if we draw the line through the center, the both of them, their shape and their size is the same. It's line symmetry. But if I just randomly cut the line like this, the upper side and the lower side, their size isn't the same, right? So it's not a proper way to check whether this pattern is line symmetry or not. Okay, so this is part for the French, math, and art. So later we're going to see another country. Okay, so let's go. The next country is Arabia. And in this country, there's Eastern culture. It's their religion. In Eastern, there's no idol, which means there's no statues or paint for their god. So the people in instead they use another form to represent their devotion for their god. They use geometry symbol. They use a triangle, square, pentagon, or hexagon to build a picture like this. And you can see this picture. It seems that there's the same type of graph, repeat and repeat. So it will look like there's no end for this picture. In math, we will call them tessellation. And tessellation is a very famous math concept for ISTED. Also, later we'll introduce a mathematician who invite a tessellation and do many applications for it. Okay, so this is a math part for Arabia. These three objects you can see over here is the polygon, which be used in Eastern culture. And we can know that we use the triangle, square, and pentagon to create the pattern, right? We create the tessellation. Also, they use the rotation to build a new symbol like this. So you can come here and play three of them to create a new polygon. And after we have the new polygon, we can create the new artwork like this. So this is the basic element for the tessellation. So you can come here and create your own pattern. So now we'll come back to Taiwan. In Taiwanese own culture, there's also some application for geometry. This is called 蓝染 integral dining. For integral dining, we use the folding and binding by rope. And after that, we can soak it in the die. After a few days or few hours, we open it, we can get the pattern like this. And this is the next concept for line symmetry, right? We cut the line through the center. We can know that the left-hand side and the right-hand side, their size, their shape, even their color is the same. So the integral dining is a beautiful application for math in Taiwanese own culture. After we introduce integral dining, volatile is another Taiwanese own culture for geometry. We can notice that most of them are line symmetry, right? We cut the lines through the center, the right-hand side and the left-hand side. Both of them, their shape, their size, even their color are the same, but one of them isn't. So you can come here to find which one is not line symmetry. Okay, so this is also an application for geometry in Taiwanese own culture. So the last part in Taiwan, you can take the mirror we prepare for you. And there's many patterns on the table. You can use the mirror to see the pattern on the table. And you can move it to get some animals. Like this, you can see there's a fish, right? So in math, it's really similar to line symmetry, but we will say it's reflection. It's also similar to line symmetry, but we call reflection is because it's from mirror. So we will use this concept in science. So it's really similar to line symmetry is because the shape and the size is the same. But you can notice that one is from the table, but the other part is in the mirror. So we call them reflection. Okay, so this is an interesting activity on this table. You can take a mirror and find the animal on the table. After we introduce the matrix unit, we'll introduce a unit in Taiwan from our own culture. And there are two kinds of unit in Taiwan. One is pin, another kind is jin liang. Pin is for area. If we want to measure area, we will use pin when we want to buy the house, right? So pin is related to Japan, and its size is approximately 3.3 square meters. It's pin. Okay, so if you come here, you can see our floor is 1 pin, approximately 3.3 square meters. Another unit is jin and liang. It's to measure the weight. So where can we use this unit? In Taiwanese traditional market. So if we go to traditional market, we want to buy the meat or vegetables, we can use this unit to communicate with vendors. Okay, so 1斤is mean 600 grams. and also is equal to 0.6 kilogram for the matrix unit. Okay. So in Taiwan, there's a very famous tourist attraction named Taipei 101. And on this board, we're going to have a small activity for you. You can use your hand to estimate the actual height for Taipei 101. You can use your hand to put on the board, and here's a marker. You can draw your hand over here, like this. So you can estimate how many hands is equal to the Taipei 101. After we measure the height of this Taipei 101 and the number of our hand, we can times the number of our hand 400. We can estimate the actual height of real Taipei 101 because the scale of this image is 1 to 400. So this is an interesting activity for you to estimate the real Taipei 101 by our hand. In UK, we know that if we want to use our body to show the unit, it's unfriendly for us to calculate it. Okay, so people decided the metric system. So in this system, we can define the unit in the same rule. So we can easy to communicate with each other by this system. And there are 7 kinds of metric units. And today we're going to introduce 2 kinds of metric unit where it's really useful to measure our height and our weight. If we want to measure our height, we can use meter or centimeter to show our height, right? If we want to measure the longer object like the road, we can use kilometer. All of them are the metric system to measure height. And for the weight, we can use gram or kilogram to measure our weight. Okay, so these 2 kinds of metric system is very useful and we are very familiar with in our daily life. And later we are going to introduce a useful tool to measure weight. If we wanted to measure the object in our daily life, we can place it on the scale and add the weight on the right hand side to balance the scale. So you can come here to put anything you want to measure, like your watch or some toy we prepare for you. Also, there's many different kinds of weight over here. So you can come here to place them on the scale to measure their weight. In this machine, we can use the items in our daily life to measure the weight of animals. So here are 5 animals you can choose. So I choose a cat. So you can take the card of cat, put it in the sensor, and you will get the item like pineapple in our daily life. And we can use the weight of pineapple to estimate the real weight of a cat, like this. So you can find the animal's weight. Also, you can put the card in the sensor again, and you can get the different items in our daily life, like pizza. So you can use a different item to estimate the real weight of different animals. So you can come here to play different kind of animals and estimate their real weight. After we introduce so many countries, we know that each country have their own language and their own culture, right? In math, we also have our language, it's unit. But unit in different countries, they have their own unit. In UK, the king just say, when I raise my hand, the distance from the tip of my thumb to the tip of our nose. This distance is 1 yard. And also he say, what is 1 foot? It's the average feet of 16 adult men. You can know that 1 yard and 1 foot is from our daily life. This unit is from our daily life, but the real length of them is over here. 1 yard is equal to 3 foot, and 3 foot is equal to 91.44 centimeters. You can know that it's really hard for us to communicate and calculate, right? But both of them is from our daily life. Yes, so it's a really special unit in United Kingdom. But later we are going to introduce some useful and friendly unit in the world. Okay, so this is a unit in UK. Now we're going to introduce the country named Netherlands. In this country, there's a famous mathematician named Escher. Here is his picture. He's not only good at tessellation, but also good at optical illusion. What is optical illusion? Look at this work of art. This is named waterfall. We know the water will fall down because of gravity. But you can see the water will return to the top of waterfall. It's a really interesting example for optical illusions, and it's decided by Escher. Okay, so later we will introduce another kind of optical illusion for some 3D models. For these two 3D models, we are going to introduce some 3D example for optical illusions. The first one is named Schroeder's staircase. So you can see I put the dinosaur on the model, right? And it looks like that it's on the bottom of the stair, right? But we can see in the middle, the reflection of it, the dinosaur seems stand on the top of the stair, right? It's really cool. I changed the position over here. In the real model, we can see the dinosaur is stand on the top of the stair, but in the mirror, the reflection of it, the dinosaur is stand on the bottom of the stair. It's quite strange, right? Because we just introduced the reflection. We know their shape, their size, also their color might be the same. But in this case, it doesn't make sense, right? Why did this case doesn't make sense? Because of the optical illusions. When we say the stair, we might come up with the 3D case, right? The stair we can go up and down. But in this model, the real one is that it's the 2 dimensions plane. So we can create the picture like this. You can see it looks like a 3D picture, but actually it's just the 2 dimensions plane. Okay, so this is a optional illusions example, one of them. And the other one is a very famous pattern in math. It's named Penrose triangle. In here, you can play this 3D model to observe the Penrose triangle. But you may notice that we can create the Penrose triangle in our real world. But where can we find the Penrose triangle? In the mirror. In the 2 dimensions world, you can see the Penrose triangle in the mirror. So if you have a chance to come here, you can play these 2 kinds of 3D models and experience the optical illusions. Okay, so in this year, we know that the ChatGPT is very famous, right? But before a few years, the AlphaGo, the algorithm, and big data is the most famous math concept in the world. And what is big data? Just like Google and YouTube. So if we open our YouTube app, the homepage, there are a lot of video on our homepage, right? But for different people, the video on our homepage is different. Why? Because of the channel we subscribe and the video we just stream. So YouTube will base on big data to recommend you some videos that you might interest in. So this is big data, and there's a lot of application in our real world. And here is a machine. There are many questions for you to answer. So for example, there's a question in this machine. For every 100 people in this world, how many of them will wash their hands after going to toilet before pandemic? So you may have some concept. Many people will say over 80 people, or even say 100 people. But the real answer is 19. Only 19 people will wash their hands after going to toilet. Because the concept is focused on Taiwan or the Asia country. But my question is for the whole world. So you may think it's incredible, right? But it's a real case. So you can come here to play the machine. The answer will impress you. Okay, so this is a part of big data. After we traveling around the world and learn so many math concepts and stories, we invite you to come here and have fun with math. Thank you.